afternoon, one and all. Myself, I am Dr. Parves Mohammed, Associate Professor, Department of CSC, Marri Laxman Reddy, Institute of Technology and Management. Today, I am going to explain about normalization in DBMS. So, normalization in DBMS is an important aspect of the database system. Basically, normalization helps us to remove multi-value dependency. The basic definition of normalization is removing multi-value dependency. Okay, the multi-value table data can be removed and it will be applied in a single structure. So, if you see the normalization process, it is an organization of data and removing of multiple values. Normalization is to minimize the redundancy also. To avoid the data redundancy, normalization concept is used. Meanwhile, in the normalization, there is a anomalies concept. In that anomalies concept, we have insertion anomalies, deletion anomalies, and modification anomalies. Insertion, which does not accept the multi-values, and deletion anomalies, which helps to delete the data what we have repeated, and modification anomalies, which helps us to modify the data to do not perform data redundancy. So, to perform the concept of multi-value dependency, to perform the removing of multi-value dependency, we use normalization. As you know, normalization is a data redundancy concept and it avoids for dividing of large data into the smaller form. The large data can be implemented into the smaller form and we have few advantages. So, the basic advantage is normalization helps to minimize the data redundancy and it creates overall data of the organizations. It helps us to avoid the multi-value dependency. Whatever the multiple values are there, the decomposition of the table is possible in normalization. Removing of multi-value dependency is nothing but, for example, we have a table. So, in that table, if you have multiple values, consider as a student who know different types of languages. So, in an entity, in a attribute, we will type multiple entities, multiple records. To remove that multi-value dependency, we use normalization. And if you are using normalization, it will be much flexible for a database design and it will be effort for implementation of data integrity concept. Data integrity concept is one of the major aspect of DBMS. Integrity concept helps us to perform the entity integrity, referential integrity and action assertions. And action assertion is a part of normalization. If you look after the applications of normal forms, the applications of normal forms are data consistency, data redundancy, response time, database maintenance and database design. The data consistency, the meaning having the definition. If our data is in a single structure, if the multi-value dependency is not occur and if the data is in a single structure, then we can say that it is a consistent data. Maintaining of data consistency is a crucial factor of DBMS. So, for that we use normalization and this consists of helps us to prevent the inconsistent errors or inconsistent of the data. The inconsistency of the data that is can be avoided and a single implementation is possible in normalization. The data redundancy is also one of the key aspect of normalization. Response time, how the normal forms are applied, how the normal forms are used, related to that the data response time will be increased and along with the data response time the different types of data implementation factors are used and database maintenance. One of the major fact of DBMS is data maintenance. If you are maintaining the data in a consistent form, if you are maintaining the data in a appropriate structure, then you can say that the data will be consistent and the data will be maintained in a proper. And a database designing, of course, it is also one of the flexible implementation for normalization. And here on the screen next we have types of normal forms. We have 6 types of normal forms. In that, first normal form, second normal form, third normal form, and BCNF, Boy's Card normal form, fourth normal form, and fifth normal form. All these are all the normal form types. So in this normal form types, here on the table you can see there was a short description is given. You can see here the first normal form 1NF, it contain atomic values. Atomic values, basically the values which are in a simple structure and the values which are not repeated. It is in a unique form. Such that type of unique form values, we will say that it is atomic values. And the 2NF, a relation is in 2NF if it is said to be in 1NF, as well as it should perform the functional dependency. Non-key attribute, whatever the non-key attributes are there, we have keys. Basically we have keys, relational keys are there. The different types of relational keys are primary key, composite key, candidate key, secondary key, and foreign key. While we are designing the table, we will take primary key. For a table, if you are using employee ID, the employee ID must and should have a primary key. The major advantage of this primary key is, if you are using primary key, the unique data can be accepted. The data cannot be repeated in the entities or in the attributes. So implementation of unique values that can be possible in the primary key. That primary key will perform the role of entity integrity. Entity integrity is a constraint where the primary key is used and it avoids the duplicate values. If you applied a primary key, it avoids the duplicate values. So that will be, we will see, we will look after in 2NF and 3NF and other normal forms. Next we have 3NF. 3NF, a relation is in 3NF is said to be in 1NF and 2NF, and it should perform the dependency concept. And for BCNF, BCNF is stronger than 3NF, and this BCNF, Boy's Card normal form, which will be used for the above all normal forms and performs transitive or partial dependencies. And next 4NF we have 4NF, fourth normal form. The fourth normal form, the above all the normal forms that will be applied in the fourth normal form and performs multi-value dependency. And fifth normal form, the fifth normal form, above all the normal forms, 1NF, 2NF, 3NF, BCNF and 4NF. Among all the normal forms that is used in the 5NF, and a relation is in 5NF that does not contain any joint dependency. Whatever the joints are there, the joint dependency cannot be implemented in the 5NF. So now we will start our normal types. So let me start with first normal form. So first normal form, the removing of multi-value dependency, I said in the normalization definition, the removing of multi-value dependency that can be exist in the first normal form. So you can see here a relation in first normal form that can contain an atomic value, single values. Whatever the single entity values are there, that values are performed in first normal form. It states that the attribute of a table cannot hold multiple values. If you hold multiple values in a column, if you hold multiple values in an entity, then it is not at all first normal form. The first normal form always accepts, 1NF always accepts single atomic values, single type of values. Here it is there, the first normal form disallows multi-valid attributes or multiple values. That multiple values we'll see the example. the relation of employee table in 1NF because of multiple values. So if you see the example, employee table is there. In employee table, we have employee ID, employee name, phone number, and employee state. If you look after employee ID is 14, employee name is John, and employee phone number. Usually an employee have 2 numbers. And next, employee state. So the decomposition of the table is performed here in the first normal form. The decomposition of the table is allowed in the it is there in the first table. It's there in the first table. That decomposition of the table we have removed in the second table. You can see the example. The first table 14 is employee ID, John, and employee phone number. The decomposition is implemented, and you see the second table, the first normal form. The employee phone numbers are different, and employee name and employee ID. So the multiple value dependency, the removing of multi-value dependency is existed in the first normal form. Then second normal form. In 2NF, second normal form, all the first normal form properties, whatever the first normal form properties are there that we have used, and the 2NF is always exists with a non-key attribute are fully functionally dependent on the primary key. Non-key attribute, primary key is an entity integrity constraint. It is an entity integrity concept. So here we have a table. In this table, the entity integrity is existed with primary key. Okay, so the primary key which does not accept duplicate values. It will not at all entertain duplicate values. So the single values can be allowed by using primary keys. We will apply single values. So the non-primary key entities are fully functionally dependent on the primary key. Let us assume here in the example I have taken school data, and in the school data let us assume that we have a school data. So in the school data you see teacher ID, subject, and teacher age. 3 entities I have taken. Teacher ID is 25. Subject, a teacher can teach multiple subjects. So 25 teacher ID whose subjects are chemistry and biology, and teacher age is 30 and 30. So here in this table the values are repeated. The values are repeated in the table because a teacher who can teach multiple subjects. So subjects are given, 2 subjects I have taken, chemistry and biology. Teacher age I have taken, and as well as teacher ID I have taken. If you look after the second example, same example, second slide. If you look here, the teacher ID and teacher age is given in one table. Teacher ID and subject is given in another table. The teacher ID is 25. As I told you earlier, the teacher ID is 25 whose subjects are chemistry and biology, and her age is 30 and 30. So here teacher ID and age was given. Whatever the repeated values are there in the previous table that are decomposited, and they were applied in a unique structure. It is in a unique structure. Now in this unique structure, the age and teacher ID are the unique values. Teacher ID is 25, 47 and 83, and the teacher is 30, 35 and 38. And whatsoever they have teach the subjects, so that subjects are different subjects, and that subjects are applied with the help of teacher ID. So as I told you earlier, the teacher ID details are there, and in the second table we have teacher ID and their subject. Here what is happening is, all in the second normal form, non-key attributes, whatever the non-key attributes are there, that non-key attributes are fully functionally dependent on primary key, and we have to remove multi-value dependency. What is there in the first normal form that we applied? So first normal form property we have to apply, first normal form concept we have to apply, as well as non-key attributes are fully functionally dependent on the primary key that we applied. So a table is decomposited into the 2 formats, and in these two formats, teacher ID, teacher age is in the first table, and the teacher ID subject is in the second table. Here we have decomposited the table. We have decomposited the table and we applied the second normal form to do not perform the multi-value dependency, because whatever the normal form we are applying, either it is 1NF or 2NF or whatever it is, our primary goal is removing of multi-value dependency. We have to remove multi-value dependency. While we are performing this concept, there will be different types of tables, and the existence of tables can be possible with a different type of records, and with the different types of records, we remove multi-value dependency that is performed in the every normal form, especially in 2NF, 1NF concept is applied, as well as non-key attributes are fully functionally dependent on the primary key, and that primary key is applied to the teacher ID. The teacher ID I didn't repeated in the second table. The second table is having a primary key, that is a teacher ID. Next, we'll move to third normal form, 3NF. The third normal form performs existence of above two normal forms. Whatever the previously two normal forms we have discussed, 1NF and 2NF, the 1NF and 2NF concepts are used in the 3NF, as well as 2NF does not contain a transitive dependency, partial dependency, that we'll use here, and 3NF is used to reduce the data duplication or data duplication. If the data is repeated, the data usually it will be removed from the table, and it is also achieve the data integrity concept. So we will achieve the data integrity concept, as I told you earlier, an integrity concept that can perform entity integrity, referential integrity, and action assertions. So the no transitive dependency for non-primary attributes, and a relation must be in the third normal form. No non-key attributes that must be performed, and a third normal form, it holds at least the following conditions. Every transitive dependency that can be performed, a transitive dependency can be existed, as well as in third normal form 1NF comma 2NF, the 1NF and 2NF along with 1NF and 2NF transitive dependency can be exist. Okay, if you see the example, it is an example, employee table is an example here. I have taken employee ID, employee name, employee zip code, employee state, and employee city. So here employee ID is unique, employee ID 222, 333 employee IDs are there, employee names and employee zip code, and we have different types of employee state and city. Now the non-primary key attributes, here employee ID is a primary key, okay, and the employee zip code is a primary key. So first of all, let me tell you what is a transitive dependency. The transitive dependency, if one entity is dependent on another one entity, and that entity which is dependent to some other entities, then we can say that the transitive dependencies happened, the transitive dependencies existed. So a transitive dependency that can be performed by the role of dependency. The dependency role, whatever the dependency, data dependency is there, the data dependency is existed in the transitive dependency form. So here the above table, employee ID, employee name, and other entities are given. So in this we will discuss about one more point, that is candidate key. So candidate key, if any entity which is not having a primary key, even though it is not having a primary key, but it will act like a primary key. So if any entity which is acting like a primary key, then that key is called a candidate key. So here the non-prime key attributes except employee ID, all the entities which are having non-prime key attributes. So employee ID is given primary key, and other entities which are not given primary key, Now we will decomposite this table into the two formats. You can see easily here the first table is there and second table is there. The first table is a employee table and the second table is a zip code table, employee zip table. So in the employee table, the employee IDs, employee name and zip code is given. The employee zip code, third column, whatever the third column is there, that I carry forwarded into the second table. So that is called employee zip code, employee state and employee city. Here, this is a primary key entity. This entity does not having a primary key, but this entity which was used in the employee zip table. Now, here what is happening? The employee ID is having a primary key. Now, employee zip code is dependent on employee ID. Okay. And in second table, the employee state and employee city, both the entities are dependent on employee zip code. So, here what is happening means transitive dependencies existed. The transitive, we are performing the role of transitive dependency. A transitive dependency is a dependency where an entity which is dependent on another one entity, or the multiple two entities which are dependent on a primary key entity type or a primary key attribute. So here in the first table, employee ID is having a primary key. In the second table, we don't have primary key in the second table, but we decomposited the second table from the existence of first table. So employee ID is having primary key and employee zip code entity which is truly dependent on the employee table, employee ID, and this employee ID is having a primary key, and this can perform with the help of employee state and employee city. So employee state and employee city are the two entities which are associated with employee zip code, and employee zip code is dependent on the employee ID. Once again I am repeating, the employee state and employee city are the two entities which are dependent on employee zip code. Because of employee zip code, we can identify the employee state and employee city. So this employee zip code, which is a transitive dependent on employee ID. It is a transitive dependent on employee ID. Employee ID is having a primary key. Employee ID is having a primary key, and this employee ID is associated with employee zip code, and employee zip code is dependent, employee state and employee city are dependent on employee zip code, and employee zip code is dependent on employee ID. So the implementation of decomposition is occurred here, and we perform the role of 1NF, 2NF, 1NF removing of multi-value dependency, 2NF non-primary key attributes are fully functionally dependent on primary key. The two concepts we applied in this table, and by performing the role of transitive dependency. All these things get together, it will be implemented in the 3NF, third normal form. Next, Boy's card normal form, BCNF. We have another type of Boy's card normal form. Along with 1NF, 2NF, 3NF, we have BCNF also. So BCNF is a normal form, that is an advanced version of 3NF. You can say that it is an advanced version of 3NF. Meanwhile, you have to know what is happened in the 1NF, you have to know what is happened in the 2NF, and you have to know what is happened in the 3NF. Whatever the things we applied in 1NF, 2NF and 3NF, that implementations we will carry forward to the BCNF, and in BCNF, functional dependency. There in the 3NF we have done transitive dependency. Here in BCNF we will perform functional dependency. So what is a functional dependency? A BCNF should always perform the role of 3NF, and a functional dependency is a dependency that can be exist with depending the values on one or multiple entities, one or more multiple entities that can be existed with a dependency role. So that is possible in the functional dependency. Let us assume that here I have taken another table, different type of table for BCNF. So here let us assume that there is a company where employees work in more than one department. Of course, there are different types of organizations. There in every organization, various types of employees are working. So I have taken a company where multiple employees, different types of employees are working in the different types of departments. So you see, employee ID is a one column, one entity is given in the employee ID. Next, employee country, employee department, where employee is working, employee department, department type, which type of department it is, and employee department number. I have taken 4 numbers, 283, 300, 232, 549. These 4 are the employee numbers, department numbers, sorry. So, in the functional dependency as follows. Now you see the role. Employee ID is dependent on employee country. This employee ID is dependent on employee country, and employee department, which is dependent on employee department type and employee department number. Employee ID is dependent on employee country, and employee department, which is dependent on department type and employee department number. Now we will see what happens in BCNF. You see the second table. So here in the BCNF, employee ID. So the table is not in BCNF because neither employee department nor employee ID are alone having the keys. Now to cover this, what we will do? I have decomposed the table, the above table, whatever this above table is there, this above table I have decomposed into the 2 forms. Now you see here, I have decomposed the table into the 2 types, that is employee country table and employee department table. Employee country table having 2 columns, 2 attributes, employee ID and employee country, and the employee department table having 3 attributes, that is employee department, department type and employee department number. So the employee ID 264 and 264 which is belongs to employee country, and the employee department designing, testing, stores and developing. These 4 departments I have taken. So for the department type and employee department number I have taken. Now by using the decomposition concept of these 2 tables, country table and employee department table, my BCNF table was implemented as employee department mapping table. So in this employee department mapping table, the existence of the above 2 tables, whatever the existence is there in the above 2 tables, that is employee country table and employee department table, with the help of that existence of above 2 tables, my table, third table, that is employee department mapping table. So in this, whatever the primary key entity is there in the above table, that I have taken employee ID and I have taken employee department number, because employee ID is having here, employee ID should not be repeat, okay, and employee ID is having different types of department numbers. So the employee ID, if employee belongs to 283 department, his ID will be D394. So that we can identify by seeing department type. There was a column that is department type. This column data is carry forwarded to employee ID and we have taken into the employee department. So you see the functional dependency, as I told you earlier, the functional dependency is existed with employee ID, it stands to employee country, and employee department, it stands to employee department type and employee department number. So employee type and employee department number, these 2 factors, these 2 entities, these 2 attributes which are truly dependent on the employee department, and the candidate key can be exist. For the first table, the above first table here, the candidate key is employee ID. You should know what is a candidate key. Even though we didn't apply a primary key, but the existence of primary key, the role of primary key is implemented with the help of candidate key. And for the first table, employee ID, and for the second table, the candidate key will be employee department, and for the third table, the candidate key will be employee ID and department. So with the help of these 3 candidate key attributes, we have performed the role of functional dependency. That role of functional dependency is possible in the BCNF, Boy's Card normal form. Next, we have another type of normal form, that is fourth normal form. A relation will be in 4NF if it is in BCNF and has no multi-value dependency. As I told you already, every normal form that should be having some type, some concept, and that concept should carry forward to the another normal form. If you see 1NF, removing of multi-value dependencies existed, and if you see 2NF, the concept of 1NF, the properties of 1NF is applied. Along with that, non-primary key entity is fully functionally dependent on primary key. If you see 3NF, the role of 1NF, 2NF, along with that 1NF and 2NF, transitive dependency is possible. And if you just now we have discussed about BCNF, in BCNF, the concepts of 1NF, 2NF, 3NF and functional dependency can be exist. Now we came to fourth normal form. So as I told you earlier, the BCNF relation, it should be a relative form of BCNF. So 4NF is a relation will be in BCNF and it has no multi-value dependency. So BCNF concept, along with that no multi-value dependency. For dependency role, we will see one more table, another table. Here we have a table, the dependency of A tends to B, and in a single value, a multiple value point of view, the dependency can be exist. That is the first fact. And the second point is, a dependency A tends to B. If an entity is dependent on another one entity, then we can say that the dependency is existed. So here you see the example of 4NF. Student example I have taken. In this student example, student ID, course and hobbies. Student ID 21, 21, 34, 74, 59. I have repeated an ID, but courses are different. Computer and maths, chemistry, biology and physics. And hobbies I have taken. So in the given table, the given student table is in 3NF, but the course, hobby, the course and hobby, both two are the dependent entities. These two entities which have, there is no transitive dependency, and the course and hobbies are dependent each together. So in the student relation, if you see student ID 21, the student ID 21 who is having computer course and maths course, whose hobbies are dancing and singing. So the two entities which are having different type of data, but their ID is same. So now what we will do is, to make the table in 4NF, we decomposite this table into the two formats. We decomposite this table, we broken down the table into two types. You see the first one and second one. The first one student course and the second one student hobbies. I have given two names, two different names, that is student course and student hobby. If you see student course, there I have taken student ID and course. Student ID is 21, course computer. Student ID is 21, course maths. Student ID 34, chemistry. Such this way I have taken one table, that is student course, and this is one table, and the second table I have applied like this. This is the second table, student ID, okay, and the hobbies. Now I decomposited the data, okay. So with the help of this decomposition of the data, so here what we have done, the data whatever is there, course and hobbies. Here 4NF having a table. So in this course and hobbies, the two entities decomposited into the two different types of tables. So here you can say that the 4NF is having multi-value dependency. Okay, dependency is there. So dependency is there and has no multi-value dependency. Dependency is there, but there will be no such type of multi-value dependency. So such that you can say that single value dependency is possible. Here all these entities which are dependent on this ID, and here all these entities which are dependent on student ID. The column of course, the entity of course which is dependent on student ID, and the entity of hobby which is dependent on student hobbies. So here we have performed dependency, but we didn't go for multi-value dependency. So a 4NF says that a relation will be in 4NF. You can say that if a relation is in 4NF or not. So you can say that if the relation is having BCNF concept, BCNF properties, and along with that, the dependency, single value dependency, if it is happened, then you can say that it is a 4NF. No multi-value dependency is possible in the 4NF. So that we have used, that we have applied in the 4NF. Then we will come to the last type, that is fifth normal form. So this fifth normal form, we can say that a fifth normal form is a relation is in 5NF if it is in 4NF and does not contain any joint dependency, and joining should be lossless. So here we have to know about joins. What is a join? Join is a concept where the data will be dependent from one entity to another entity or from one table to another table. There will be multiple entities or there will be multiple tables. So here the 5NF is satisfied when all the table data that should be broken down into the many components, many tables. Okay, and the possibility of lossless joins, that we have to look after, that we have to see. So 5NF is also known as project join normal form, PJNF. This is an advanced name. Most of the textbooks, most of the materials, they will give only 5NF. But if you want to know one more name of 5NF, you can say that project join normal form, PJNF. Now see the example of 5NF. The example of 5NF, here I have taken a subject, lecturer and semester. It is a student data. So I have taken different types of subjects, computer, maths and chemistry. And here I have taken different types of lecture names. And here I have taken semesters. You have to focus on the semesters. So the fifth normal form table is decomposited. Subject, the same table I drawed here. Subject, lecturer and semester. In the above table, one person, one faculty is there whose name John. He has taken two different subjects, that is computer and maths, and whose service is given to the semester 1. Then that person John, he does not take in maths subject in semester 2. Just now I told you, in this table you should focus on semester entity. Even though I have taken different types of lectures and different types of subjects, but my key concept is semester. I have taken two different semesters, semester 1 and semester 2. So one faculty, I choose one faculty whose name John. So the John faculty who taught in semester 1, but he did not take any subject in semester 2. Next, in this combination, suppose for example I would like to add the data, and the semester 2 and semester 3 we want to update. So now what we have to do? The null values, if the semester data is not at all existed, then we can say that the null values were applied. But the columns, primary key columns, to do not break the column data, so the 5NF will be implemented by performing joint dependency. So what will be a joint dependency? Now you see, I have divided the same table. The table is one, but I broken down the table into three pieces. That is P1, P2 and P3. P1 table, you can see on the screen, P1 table, I have selected semester and subject. P2 table, subject and lecturer. P3 table, semester and lecture. So the P1 table first entity and the P2 table second entity, that I have used in the third table, P3 table. So semester 1 subjects are computer, semester 1 subject is maths, semester 1 subject is chemistry, semester 2 subject is maths. So semester 1 3 subjects, semester 2 1 subject. Then the subjects, computer subject who's handled by so and so faculty, computer subject faculty name, like that I have given lecture names. Next, now here I done the implementation of P1 and P2 table. Whatever is there in the P1 table and P2 table, that data I have taken, I carry forwarded and I applied as a semester and lecture. So what are the different types of semesters? Semester 1, here semester 2 and semester 1. Now you can observe here a faculty who teach in semester 1, his data is carry forwarded, his data is followed in the semester 1, that is so and so faculty. John is a faculty who teach semester 1 subject only, but he have taken 2 subjects. The John faculty has taken 2 subjects, that is computer and maths. The decomposition I have done here, and another one faculty is there whose name Praveen, chemistry, subject is chemistry. The data is applied in the single structure, that is semester 1 Praveen. So P1 table, P2 table, P3 table. P1 table semester and subject, P2 table semester and subjects, and P3 table. So the above 2 tables that can be applied here, 3 tables, and now I will conclude my session. So in this normalization technique we have discussed all the normal forms, but meanwhile before that, removing of multi-value dependency. The removing of multi-value dependency is existed, and the all the normal form 1NF, 2NF, 3NF, BCNF, 4NF and 5NF. Okay, so these are all things what we have discussed in the normal form. So the basic conclusion, basic implementations of normal forms is role of multi-value dependency is removed. The multi-value dependency is removed, and every normal form that can perform different types of applications. If you look after 1NF, 1NF will be removing of multi-value dependency, and if you look after 2NF, 2NF is along with 1NF, non-primary key entities are fully functionally dependent on primary key, and if you look after 3NF, 3NF performs transitive dependency, 4NF above all normal forms, and dependency rule, functional dependency, and 4NF. If you see 4NF, 4NF above all normal forms, along with that BCNF, and along with that BCNF, the single value dependencies are existed. And just now 5NF we have discussed. In 5NF, the join implementation concept above all normal forms, all 1NF, 2NF, 3NF, 4NF, BCNF, along with all normal form, the looseless joins concept is applied in the 5NF. So join should be looseless. A relation 5NF if it is in 4NF and not contain any joint dependency. Joint dependency should not be possible. Joint dependency, joining of lossless, only lossless data can be accepted. So we no need to mention of joining, no need to mention of join concept. We have to say that 5NF is a concept of above all normal forms, that we can say. Okay, so with this I will conclude, I am going to conclude my session. Thank you.